All right, I'm skipping the next one, K. I'm skipping L as well. L would just be a U substitution. K would be something from the table. M looks interesting. M would be... Gosh, I don't know what M would be. I guess let's look at M. Integral natural log x over x plus x natural log x dx. If I had to guess, I would say first we're going to do a U substitution. If I let U be natural log x, then du is just 1 over x dx. If I factor x out of the denominator, I end up with x times 1 plus natural log x. Then if I do the U substitution, the natural log x up top is u, the x dx substitutes out to be the du, and then on the bottom I have 1 plus u. All right, at this point, you could either do long division, or you could just rewrite this so that it's two separate fractions. What I mean by that is we're going to just add a 1 up top and then subtract a 1. That way I have u plus 1 up top and u plus 1 on the bottom. That simplifies to be 1. And then I have the remainder, negative 1 over 1 plus u du. Okay, 1 is going to go to u. This negative 1 gets factored out. And the antiderivative is the natural log of the absolute value of 1 plus u. And then just substitute back in the u, which was natural log x. Oh, that was a cool question. All right, I like that question a lot. That was fun. Very rarely do you see natural log inside of a natural log. All right, but was that okay? Does that make sense? That's section 1 stuff. I mean, it's just a U substitution. A kind of a cool one. Any questions yet? Okay. N would be very long. So N, you'd have to start off with long division because the top has a bigger degree than the bottom. And I think after that, because this factors, you may have to do partial fractions. I don't really feel like doing that one. O would just be another U substitution, and here I gave you a little hint. Look out for these hints because I think on the test there may be some hints on what to do for these weird U substitutions. P looks like one of those weird trig substitution things. And then 2 and 3 down here, that's those trapezoid rule and Simpson's rule stuff. So maybe let's look at 2. Oops. So I'll read through it. For 2 down here, a brief calculation shows that if 0 is less than x is less than 1, then the second derivative of f of x is square root 1 plus x to the 4th lies between 0 and 8. Based on this, about how many subdivisions would you need to estimate the integral of f from 0 to 1 with an error no greater than 10 to the negative 3 in absolute value using the trapezoid rule? Okay, for this, because we're looking at errors of the trapezoid rule, we'll just copy down the formula. And what we want is we want to bound this entire thing by 10 to the negative 3. 10 to the negative 3 is 0.001, just moving that decimal over 3 times. You can think of it like you have 3 decimal points. Other than that, we're just plugging stuff in. It doesn't ask us to find the maximum of the second derivative, it just gives it to us. The second derivative of the function is between 0 and 8, which means that the m is going to be 8, since that's the maximum of the second derivative. B minus a is the interval. We're going between 0 and 1. So 1 is going to be the b minus 0 for the a, and that's cubed. That's all going to be divided by 12n squared. We do not know what the n is. That's what the question's asking us to find. It's asking us to find the number of subdivisions. So what we'll do is we'll multiply the n squared over, we'll divide by that 0.001, and then just take the square root. I have my special calculator. So on the left-hand side there, the 8 divided by 12 times the 0.001 is some big number, and we're just going to take the square root of that. So we get, always round this up, and it rounds up to 26. Do be careful if it's the Simpsons rule stuff, because with Simpson's rule, it always has to be an even number. So if it rounds up to an odd number, just pick the next even number above that. Okay, but that was that one. 3 is the same thing. It looks like 3 is more just plugging it into the sum instead of plugging it in to the error analysis stuff, but you're just plugging the stuff in. Okay, great. But is that all right? Is there any questions about any of this stuff? At all? Everybody feel ready for the test? They're all going to get hundreds? Maybe not 100. 99. Well, if there's no other questions, and you guys feel all right, don't forget that they do have those practice quizzes and practice tests in MyLabs. So just to remind you where they are. So if you're in MyLabs here, and you go to the, is it the quizzes and tests button? Let's see, where your homework is. I think if you're here and you just scroll like all the way down. Nope, I took them off. They're not there. You can go back and look at old homeworks by going into your gradebook. So if you just go into your gradebook, and then you can find all of your homeworks and you can review all of them. That's a good thing to do. The practice thing I gave out, of course, is really good. And then if you really want like extra questions, I would also recommend, if you have your book, or if you want to just pull up the copy of your e-text here from the chapter contents, look in the back of the chapter 8 chapter for the review questions. And just kind of, I wouldn't do all of them, of course, because there's like 100 of them. But I would definitely peruse through them and see if any of them are stuff that you haven't seen before. They shouldn't be, because we covered everything in chapter 8. So if something doesn't look familiar, then I would recommend trying to figure out where they got that from in the sections itself, and then doing some examples of those. Cool. I'll be around all weekend, so if you do have any last questions, whether it's from homeworks or from practice problems that you're working on, feel free to email me, and I'll try and get back to you right away. The test, I think, is due Sunday when the homeworks are due, and I would, again, recommend to upload your scratch paper into Moodle. That way I can give partial credit. But I guess that's it for today then. We will be having some of these again next week. So I'll see everybody Tuesday and Thursday next week, I hope. Other than that, have a good day. See you later.
Have a good day.
Thanks.